Hello, welcome again to SUSECON Digital and to today's session, From Containers to Cloud Native, Deliver Applications Faster to Increase Business Agility. My name is Jennifer Kotzen. I'm the Product Marketing Lead at SUSE for our container and application platforms, and I will be hosting our session today. This is a business overview session, and that means we're not going to do any technical deep dives. The content is geared toward IT managers and technology and business executives. During the course of the conversation today, we will examine some of the most challenging problems that your business is facing today as you necessarily undergo the digital transformation that will help you compete and win in the new digital economy. So let's get started. Today's agenda will begin with a look at what is cloud native and why should I care. So spoiler alert here, in case you didn't get it from the title, Cloud Native provides us with the means for delivering applications faster, and it is a key element to the future success of your business, and we'll talk about that in a little bit of detail. Then we will deconstruct the concept of Cloud Native into a number of different acceleration avenues, and we'll examine each of them in turn and talk about the value that each contributes and how collectively they come together to help you dramatically increase the agility of your business. After that, we'll drill down a little bit more closely and look at one of those acceleration avenues, which has to do with lifecycle automation. It's a really important one, and we have some experience there that we can share. And then we'll wrap up very briefly at the end with a little introduction to what SUSE can do and some pointers for where you can find more help from SUSE and how we can help you be successful in your journey toward cloud native. So let's begin. What is cloud native and why should I care? Well, before we flip the slides, let me just say something really important. Cloud native, contrary to many popular assumptions, is not about where an application runs. Rather, it is about how an application runs. And we're going to talk about how applications run and how they are delivered helps you improve your business. Because this is a business conversation, we're going to start like any business conversation should start, with the customer. Okay, to be successful in business means we need to have happy customers, means we need to ensure that the experience that those customers have with us is a great experience through every piece of engagement that they have with us, from the time they first discover our product or our company to the time they purchase it, to the time that after that, they engage with us about support, even the engagement they have with us in terms of what the product delivers itself. All of those need to be really great positive experiences to ensure that that customer will come back again and will tell others to use our business, right? So the idea of engaging and providing great engagement with those customers is absolutely critical today, as it always has been, to winning in business. But what's different today is that customer engagement is increasingly performed and managed digitally. Think about it, when you market to your customers, it's done digitally. They come to your website, right? When they place an order, they may do that on an online shopping cart. When your customers are working with your services and your support organization, a lot of that happens technologically as well through software. And even in the products we deliver, technology and software that delivers that technology is key to the value that's driving differentiation in our products. So if you think, for example, about your car, right? When you want to purchase a new car, you're probably looking at the infotainment system in that car. And that infotainment system is largely software. If you're lucky enough to own a Tesla and you take that Tesla in for maintenance, do you know how you get maintenance on a Tesla? That's right. You get a software upgrade. That product, that car, is maintained via a software upgrade. The features that people care about in that car are software features, and they're delivered as software applications. So my own experience here, we're facing the COVID pandemic. I wanted to get groceries, right, without having to go to the grocery store. So what did I do? I went online, and I found a grocery store that made it possible for me to fill up a shopping cart online and arrange for pickup at a local store near me. The grocery store that was able to offer that capability to me fastest won my business. They were able to turn on a dime in the changing economy and provide a new service, a new capability through software that won a new customer. So the ability to provide engaging experiences, the ability to respond to changing business environments is always important. And today, the way we do that largely is through software applications. That's what we mean by living and breathing and winning in the digital economy. So as I mentioned, the way that we help you deliver those applications faster so that you can be more responsive is using an approach that we call cloud native. So let's talk about that approach, and to put it into context, let's compare it with the approach that we've been using and with which you may be well familiar, the approach we've been using for, 40 years now, a long, long time. So the approach involves a lot of things. It involves the architecture of an application. It involves a process through which an application is delivered. It involves organization models and teaming structures. And altogether, that's what we mean when we're talking about an approach. All right. So the traditional approach is one in which our application is a large, what we'll call monolithic application, symbolized on this slide with all the little hexagons, looks like a beehive inside a rectangle. That's a large monolithic application. It's monolithic in that it cannot move through the cycles of the stages of its life cycle. It has to move as a whole unit. Okay, that whole block has to move through each phase as a whole block. And because it's a large block of code, it means that the teams that work on it in each phase have to be large too. It takes a lot of developers to create a large piece of code. It takes a lot of testers to test a large piece of code. So we have large organizations, and since they're large at each phase in the cycle, the consequence is that an organization tends to be, is organized by function. So we have test engineers, we have release engineers, we have software engineers, right? And that's how we're organized. So the structure of this application drives a lot that has to do with how we're organized and how the process for moving the application through its life cycle happens. It's predicated on the nature of the application. We have these interdependent components, functionally organized teams. The release model is focused around the needs of the application, and the consequence is that it takes us, and has historically taken us, probably 12 to 18 months to put out a new software release. If you go back 10 years or more, you'll know, 2 years for a new software release was not atypical. Now today, we all have cell phones, and they're updating every night. We're getting new capabilities delivered through those apps all the time. The impatience of our customers is real. The expectation that new capabilities will be delivered very fast, immediately, and as soon as one competitor has it, you better have it too. That's the new model. And using this model, the traditional model to release software to your customers and your partners, is not going to cut it if you want to stay ahead and if you want to win in the digital economy. So this is where we need to change the model. And we're going to talk about a cloud native approach as the approach that can help you win. It is, again, an approach that has a lot of different pieces to it. It's not just an architecture piece. It's not just where the thing runs, okay? It incorporates a lot. So fundamentally, one of the things is that monolithic application is broken down into smaller pieces, which we call microservices. And each of those microservices is independent. That means that it can be deployed independently, and it can move through each stage of its life cycle separately from all of the other components. Okay, so it's small, it's independent. Now the blue microservice can move through whenever it's ready to go. It doesn't have to wait for the red microservice to be ready to go. So this means now that I can move new features and functionality incrementally. Smaller increments can be released and delivered more frequently. So, in 2 years, I may be delivering the same amount of functionality, but I'm delivering it incrementally much more frequently and quickly. So my customers get access to features sooner. Because these microservices are smaller pieces of code, that means the teams that need to work on them are also smaller. And that means that they can be more agile. They can get things done more quickly, as always happens when you have a smaller team. That also helps accelerate the process. And perhaps more than anything else, the aspect of cloud native that makes it possible for us to deliver applications faster is that it's predicated on the idea that the whole workflow is automated. All right? So whereas the previous workflow that was built around the needs of the application, things are flipped here with cloud native. The applications are built around the need to be able to move them through an automated workflow. So to understand that, consider the analogy when we started to do manufacturing with factories. Okay, so prior to Henry Ford's assembly line, cars were created as one-off custom creations, and they were wonderful one-off custom creations. But when we put a standard process for automating the delivery of cars, right, now the productivity, the throughput is incredible, right? We have a consistency, we have a quality improvement, we have a speed improvement, and we have a volume of production improvement that's unmatched if we don't have sort of an automation-focused approach to how we're going to deliver things. And that's what Cloud Native also brings to the table, this focused standard way of deploying applications that can be highly automated so we get very high throughput and allows us to take all of these new microservices. Remember, we're going to have lots of microservices instead of one application, so we're moving a lot of things through this pipeline. We need to be able to do that quickly and efficiently in an automated way. When we take all of these things together and we implement them collectively, we now are implementing a cloud-native approach to application delivery. And when we do that, we see our cycle times dramatically reduced. So now we're releasing software every month, or we're releasing software every week, or every hour. In some cases, there are companies out there that are releasing software in the scale of minutes. Okay, so new capabilities continuously being introduced to keep up with the needs of our customers. When we embrace this approach, what does it really mean to the business? Let's up-level it a little bit. Starting on the right, the cloud-native approach improves our processes. They make us more productive and efficient when we have these automated processes. Also, the reliability of our releases is improved, and we'll talk about this a little bit later in more detail, but in general, we remove a lot of the fear that comes from releasing software, and with a standard and automated process, we remove a lot of the human error as well. Finally, we release the software faster, and that is the goal. Get the software out faster. When we get the software out faster, then that translates over to the better product side, right? If we have software that's available in production sooner, now our users can get their hands on it, and we can get feedback on that, and we can identify early whether or not what we've done is valuable. Things that aren't valuable, we can drop. We don't have to spend the next 10 months building on a false premise that something that we thought was valuable really is valuable. We can find out early what works and what's interesting and what's not. We can change course as needed. We can become much more agile and make sure that we're building the right product that matters to our customers. We can also improve the quality of our deliverable. Why? Because now we're delivering small bits of functionality incrementally, and that means that when something goes wrong, as inevitably something will, the impact of the problem should be comparatively small. It's a small microservice. How big can the impact be? Well, sometimes it could be big, but generally speaking, the impact, the smaller the amount of code we're putting out, the smaller the impact, right? And the easier to fix. It's a small piece of code. The fix is less complicated to find the root cause and to fix. And because we have a rapid release cycle, we'll get that fix out faster. So the end result is that the problems that we do encounter are fixed rapidly, and so the quality of our software definitely goes up. So now we have the product our customer wants. It's high quality. It's delivering new features as fast as our customers need them. What does that translate into? At the business level, we have higher customer satisfaction. We have happy customers who want to engage with us, who want to tell their friends and their family, this is the company you should be working with, and that helps us stay ahead of the competition and win. So it's all tied together. Again, we're delivering digital value through applications. Our ability to deliver those applications faster helps us succeed in the digital economy. All right, that said, let's move ahead. We talk about cloud native as a number of different components that come together to define this whole approach. Let's look at those components in turn. So here's sort of a layer cake picture of the way we bring applications to market, and it sort of illustrates cloud native on the right-hand side in an interesting way. First of all, left to right, you see that if cloud native comprises the stack of things on the right, you can recognize that what's over there is actually the evolution of things that have been happening for many years from the left as we move to the right. So, for example, moving from physical servers to virtual servers to containers is sort of an evolution in how we package software. So where we're at in containers, or in cloud native, is something you should think of not as something brand new that you have to learn and start all over. Think of it again as the logical extension of things you've been doing. All right, it's just the next step in something you already understand. Yes, you need to tweak your thinking. You need to make some changes, but it's not drop everything and do something completely new. It's take the lessons from what we have learned in the past and extend them to the next step. It's evolutionary. All right, that's the sort of left to right story here. The top to bottom story here is that cloud native really is implemented at different levels, and there's a lot of pieces that come together. And when you think about the end game being getting everything implemented on the right side, it's important to recognize too that you don't have to implement everything all the way on the right side in order to achieve real business value. Cloud native is something that is very well suited to piecemeal implementation. So you can start by packaging in containers and get great value and get tremendous value out of that. And later you can say, all right, I want to start to think about implementing a microservices architecture. And later I want to start thinking about moving to DevOps. Each of those things can be done independently, and you don't have to have them all done before you realize real benefits and start to deliver applications faster. So that's two important things there. It's evolution, and you can implement piecemeal. Let's take a look at some of these pieces. I'm not going to spend a lot of time on the infrastructure piece because I think we all understand that pretty well. Moving to cloud infrastructure is essential. And when I say cloud infrastructure here, I'm not necessarily talking about where something runs. Again, I'm talking about cloud infrastructure, just to back up here for a minute. Cloud infrastructure in this model means self-service access to dynamically provisioned resources that I can quickly get and release when I'm done with them. So it's that self-service access and the flexible use of resources for the user that defines what we mean by the application infrastructure being cloud. All right. Above that, though, let's start talking about the newer concepts we'll begin with containers. So if you're not already familiar with containers, you should get familiar with containers. They're a really important part of the future of anybody who's involved in technology today. Important to recognize that in your business, the adoption of containers is going to start in your development team. All right, so there is value to containerization to your IT team. They're small and you can improve utilization of your resources with containers. But before you can do that, an application has to be built in a container, and the adoption of containers is going to be driven by your developers. And they want containers. They love containers. And the reasons developers love containers are numerous, but high among them, number one, they don't have to go to IT to get a container. Containers are lightweight. Containers start up really fast. They're small. So developers can run containers themselves without having to go to IT. They can run them on their own laptop, and that just makes their whole life so much faster and simpler already just because of that, because they can manage their containers by themselves. But even more valuable to containers is the fact that they run consistently anywhere. So containers take everything that a piece of software needs to run, all the environment variables, all the libraries, everything that it needs to run, and package it together in that container so that when I move the container from one environment to another, I can be assured that that software will run consistently wherever it goes. So in my development environment where I may be working on my laptop, I containerize something, then I move it to the test environment where I may be running in public cloud so I can do scalability testing with lots and lots of servers. Then into staging or production, I may be using virtual machines or bare metal that I have on-prem. That container will run consistently in all of those environments. And that removes the works on my machine problem, which is a tremendous impediment to rapid delivery of applications today. So that problem is where, one phase, the developer says, yeah, it works on my machine. It goes into test. It doesn't work. And we go back and forth and try to figure out what's the problem here. It's something in the environment. Containers virtually eliminate the something in my environment I can't figure out what it is problem. All right. And when we take those two things together, we get the portability and the ease of use for developers. Embracing containers allows us to increase productivity across the board and also increase the reliability of those releases. So again, sometimes there's a hesitancy to release technology into production because we're afraid. We don't like change. Change exposes us to risk of things breaking. But when we have containers, we're not changing so much, right? We know that the environment, the container will perform in a consistent way in this environment as it did in the pre-production environments. So our release reliability goes up. Definitely get going with containers if you're not already. Let's now move up to the application architecture. So we talked briefly about microservices, but the real value here in the cloud native context of microservices is that they are the key to enabling that incremental change and the shorter cycle times. Okay, so because it's a small bit of code, we can make a change to it quickly. We can run it through the process more quickly with a smaller team. So you want to start experimenting with microservices as soon as you can too. So how do you do that? Well, you have this tremendous estate of existing applications. Should you go in and refactor those as microservices? You probably should, but maybe not first. You might want to start by embracing a microservices architecture for some new application, so you don't have any kind of legacy attachments or special concerns that you have to worry about. With a new application, you can start from scratch and build it in a microservices architecture and learn what you need to learn about what's different when you build something this way. And after you get some experience with an unencumbered new application, then you can go back and take a look at some of your traditional applications and figure out how to modernize those. With the experience you've gained, you'll be better able to identify candidate areas of that traditional application that could be pulled out and turned into a container. What makes a good candidate? What makes not a good candidate? And to recognize that not every piece of a traditional application needs to be pulled into microservices. Some parts of it may be just fine left alone. But you may have a piece of that application that could be reused by other applications. Or you may have a piece of that application that would be beneficial to scale independently. We don't have to bring the whole thing along, just this piece which really manages the work, the users or some such thing. You may have a piece of the application that needs to change more frequently than others. Any time where a piece of the application behaves differently than the rest of the application, that's a good candidate for containerization. You'll learn what's a good candidate as you start by building microservices architectures, and then go back and apply that knowledge when you try to modernize your existing applications. Let's now talk about the top layer, which is the lifecycle management layer, and the layer where we have relatively more difficulty. So containers are a change, and application architecture is a change, and there are challenges in those changes. But the challenges that come with implementing this layer tend to be more difficult because they're not just technology. They involve people, they involve process, they involve culture and organization. So they can be more challenging. Anyway, let's just start at the top line. What is DevOps? DevOps in concept takes the practices that we're already implementing in dev test with agile development, so the rapid iterative releases, incremental releases of software, and extends that model to now also incorporate folks from the ops side. So we're not just preparing releases that can be deployed rapidly, but we start to see if we can actually deploy them more rapidly. We start to engage the operational questions and concerns into the application development, right? We pull and we can say DevSecOps here, right? So we pull some things left in the process. We take things that maybe we used to defer to deployment time, and we start to think about them earlier in the development process. So taking a team that's practicing Agile and incorporating, adding in an operations person to extend that model across the broader life cycle is, think about that sort of definitionally as where you're headed with DevOps. Now, when you get to this point, this is also where you're going to bring that automation in, the automation that allows us to hit the throughput and the productivity that you really need and you can't get to without automation. So automation allows us, when we're doing this process, automating the process, allows us to deliver applications at a pace and scale that we want to get to when we're working in the cloud-native world. Revisiting again now, wrapping with the fact that organizational and cultural change is part of this and that can be challenging, I'd like to shift into the next section of our presentation here, which is looking at that move, the challenges in moving toward DevOps. I'm going to break this up into two pieces, one which is really about the automation aspect and one which is about the organizational aspect. So let's start with the automation aspect. So what I'm showing now is just to help set up the slides to follow with so you don't get too much at once. This is, you'll recognize this as a workflow with the chevrons there, dev, test, release, deploy, manage, sort of a typical life cycle for how applications are delivered. And then you'll see in red some different areas of functional responsibility within an organization that's responsible for delivering these applications. So we have folks that are responsible generally in the pre-production environment for developing the application and testing it and getting it ready for release. And then we have folks that are responsible for the application administration once it goes into production. So they deploy it and they manage it operationally. And underpinning the application teams, of course, we have infrastructure, and there's another set of responsibilities that goes with supplying the infrastructure that the application needs to run on. We all recognize this. That's not new, just setting up the slide. What I want to talk about is automation. So how is automation starting to become part of this process? Well, In many organizations today, the application side, the application development side, is beginning to automate the dev test release process that they go through. So if you've heard of CI/CD, which stands for continuous integration, continuous delivery, and pipeline tools such as Jenkins, for example, which are used to automate the processes so that a developer can commit code and have that code automatically built and tested, and a release ready to be put into production sort of pops out the other end of the pipeline. That's the goal of the CI/CD, continuous integration, continuous delivery pipeline. Every time I do a commit, there's an automation that happens and produces out the other side a releasable artifact. Okay, so this process, this automation is happening today. It's not, there's a long way to go on it, but it's happening, and leading companies are very well into this. Most companies are dabbling, if not making pretty good progress. So it's happening. In contrast, once we get into the production environment, there's a whole lot less going on with automation. I don't want you to look at all the bullets here. So there's a lot of bullets on the slide, and they're not so you read them. You can go back and read them later. The point of having the bullets here is to show you that there are a lot of bullets. All right, these steps have to happen. I'll go quickly through some of them. And this is all done pretty much manually today. So we roll out a new application. If something goes wrong, we roll it back in the deployment phase. We have to give it an IP address. We have to set up load balancing across, multiple instances. We have to set up our security certificates, and a number of other things that are involved in deployment, all done pretty much manually. After the application is deployed, we have to monitor it, and we have to scale it up and down to handle changing demands. We have to monitor for failed instances and make sure that they're managed appropriately. So again, more manual work. At the infrastructure level, VMs need to be provisioned, storage needs to be provisioned, workloads need to be placed on those resources, and they have to be placed in an intelligent way so that the resources that the workload needs are the right resources. We got to match the workload requirements to the right resources. And then we have to puzzle fit everything together to try to make sure that we're maximizing the utilization of the hardware resources that we have. And of course, on the infrastructure side, we also have to watch for the inevitable server failure and make sure that we're addressing that in the best way possible. So there's a lot going on here and a lot more, all right? But this is the example, an example set of some of the things that are being managed today, not automated in most companies. And in reality, even though this looks complicated, it's more complicated. Well, I forgot. When we containerize applications, when we containerize applications, the process doesn't really change very much. The only thing that changes is that now our application development team provides containerized versions, but the process is still the same. We still have to do all the same things we did before. And if this looks complicated, the reality is the same things that we're doing in the deployment are also happening in the dev test environment. So it's complicated, right? And here the point is that our development organization is actually doing the same stuff that we're doing in production deployment. So it's really complicated. Lots of stuff going on. We can make your life better with some automation that's available today. And that is what Kubernetes is all about. So every one of the bullets that was on that previous slide is a bullet that Kubernetes automates. So you can get rid of all of those jobs we just went through by putting Kubernetes infrastructure in to manage your containerized workloads, all right? So that's great because now we have all this automation and so much less that you have to do and so many fewer places for errors, and it's wonderful. You should definitely get Kubernetes. However, you now have a different thing that you need to deal with. The challenge is you need to learn to use Kubernetes. Kubernetes is a new platform. It's a complicated platform. It's extremely powerful. You're going to like it once you learn how to use it. It does take you some time to learn how to use it, though. What's nice about Kubernetes, besides the fact that it automates all of this for you, is how you work with Kubernetes. You drive declaratively. So instead of, let's say you want to handle a failure, instead of saying in the event of a failure, do this, you don't have to write a script that says, here's how I'm going to automate my recovery from a failure. Instead, you just tell Kubernetes, I want you to always maintain 5 instances of this workload, and Kubernetes will do the rest. You describe the end state declaratively, and then Kubernetes ensures that the platform puts your workload in that end state for you. So how do you describe that to Kubernetes? You create a manifest that you feed to it, and that's simply a YAML file. And in that YAML file, you describe certain parameters that are going to be important to how you want Kubernetes to manage the application. So each player in this process is going to have a contribution to make to that manifest. So the developer may codify application deployment parameters into that manifest. They're going to put things like, what's the right version of the image to use? How many instances should be running? The release team may add in some security stuff, which microservices should be allowed to talk to which other microservices. And your security team may have some things they want to add into the YAML file there. When we go to deployment, the production deployment folks are going to have a different set of operational concerns that they're going to want to include in the YAML file. They're going to want to talk about what's the ingress, egress, and firewall issues, for example. So we need to create that YAML file, but once that YAML file is created, all we do is we give it to Kubernetes, and then Kubernetes automatically deploys and manages the application as we have to produce the end state that we have described. It's very, very nice. That said, again, you have to learn Kubernetes. There's an easier way for folks who don't want to learn Kubernetes, and that is to add a platform as a service layer into the picture. So a platform as a service, a PaaS, abstracts away the complexity of Kubernetes and makes it possible for the application teams to have a much, much simpler interaction. They simply commit their code to Git on the development side, and the entire workflow is already set up and automated. The PaaS provides for you that factory infrastructure. It gives you the workflow that's predefined. All you have to do is put it in place, and then your development team can do a commit, and out the other end is ready, a release-ready artifact. Your deployment team can then do a push when they want, and that gets deployed automatically too. So it just simplifies things for the application teams who don't necessarily want to learn how to manage all the complexity of Kubernetes. So these are the keys to automation, having a Kubernetes platform and optionally a PaaS on top of that can give you that factory scale productivity. Now let's move to organization. I said I would talk 2 points here. The organization part, I'm going to go through a couple of slides here. Hopefully you'll recognize your team in one of these or something similar. This is a very typical structure here. The dev test team is in one organization. Everybody who's pre-production lives there. And then once we go into production, the IT ops team takes over. This is a very common organizational structure. And at this point in the market adoption of Kubernetes, a lot of the dev test teams are still in a bit of an early adopter phase, and they are likely to be managing their own Kubernetes environment in such situations. Another common structure is that the IT ops team is divided, still all IT ops, but into two pieces. So you may have the people within IT ops who are responsible for infrastructure, and then a different group of people who are responsible for specific applications. Like you might have a DBA, or you might have your SAP administrator. And while they understand infrastructure, their main focus is not making sure the infrastructure is available. It's making sure that the application is available and up to date and performing well. Some organizations look at Kubernetes as just such a complex application, and will have a Kubernetes administrator and think of that person much like any other complex application administrator, so they can sort of fall into that bucket. Other organizations recognize that Kubernetes, while it is a complex application, it is software, it's not providing, business end user business value. It's still part of infrastructure that supports applications that run on top of it. And as such, in those organizations, the infrastructure ops team often takes responsibility for deploying and managing the Kubernetes cluster as part of infrastructure. As organizations evolve and mature, that infrastructure ops team will typically take over all Kubernetes platform deployment and management. It just becomes part of the infrastructure that's available, not only to the production deployment, but also to the dev test teams. And the next step in evolution is the hard one. We all know about the wall that exists between dev test and deployment, production deployment environments. We all know the developers build code and they throw it over the wall, and then it goes into production ops. And the communication between both sides is infrequent, and to the extent that we do have communication, it's often about a problem, typically an environment-related problem. Software's not working in production, fix it, right? So the conversations we do have are typically founded on a problem and can be unpleasant, and the wall is real and it's difficult to navigate through. So as you're embracing the move to DevOps, the hardest thing you're going to face is tearing down this wall, but that you must do. If you want to get to a point where you can truly deliver applications faster, you need to embrace a DevOps model where that wall goes away and we have an integrated team that's working end-to-end to deliver an application through its entire lifecycle. This is a hard transition. It's not a transition that you can make quickly or easily often. It may take some time, it may take a long time, but you can, again, take small steps to help you move in this direction. Some recommendations. One, use containers. As soon as you use containers, a lot of the consternation that exists between the production and pre-production environments will go away. The relationship should be easier. The ability to deploy more frequently should be easier just by virtue of using containers. The second thing that can help ease the relationship, just from an organizational standpoint, is using microservices. Again, those microservices introduce incremental change. Yes, it's more frequent, but each change is less scary. The consequences of a problem with each change are much, much reduced. And the fact that we can produce a fix much more quickly can also ease tension and allow that deployment team to feel more comfortable about deploying our changes at a pace that the development team is constantly pushing for, the rapid pace. Another practice that you can use is to start with a single team. Don't roll this out across your whole organization. Start with one application or one microservice. Develop the skills in the process with a team of folks who's committed and likes this idea and wants to move there. Let them go and let them learn how to do it and be successful, and then expand to another team. And when you expand to another team, drop in one of those experts that was part of the first team so that they can provide the guidance and the assistance to the subsequent team and make them more successful. So again, recognize this is a challenge. Everybody knows this is a challenge. But if you really want to succeed and be able to deliver applications faster, this is in your future. So start thinking about it now and start imagining how you're going to start to incrementally move toward an integration of these two teams. Now, the illustration here I'm showing again is how we use Kubernetes, but of course we can use our paths here and have the illustration we've seen before with a simpler paradigm for that DevOps team. And now, finally, once we have this DevOps team integrated, for the first time, we have the possibility of moving beyond continuous integration, continuous delivery, and changing that CD to the other CD, which is continuous deployment. Continuous deployment means my developer commits code, and then the automation pipeline takes that code all the way through to deployment. Happens automatically. This is where we have that full factory scale, high throughput production. Now, we can't do this for every application. I recognize that sometimes testing can't be fully automated. You need a human to be involved. Sometimes different highly regulated industries, require you to be in a test mode for a certain amount of time, so you can't take every single commit and roll it directly into production. I understand that. But increasingly over time, count on it. More and more applications will be delivered this way, and the cycle time and the approach to continuous deployment is an inevitability that your industry, and if not you, then your competitor, will embrace. So more and more applications will move this way, and you're going to want to figure out how you can move that way too. SUSE can help you in that journey. Finally, SUSE offers the technology platforms that help you, that underpin this journey and help provide the automation that you need. So SUSE CaaS platform is our Kubernetes distribution. It's intended to make Kubernetes accessible to you and usable to you as an enterprise supported platform that's exactly what you need to provide that container management. And SUSE Cloud Application Platform sits on top of Kubernetes and provides that enhanced developer experience so you can really enhance productivity and get to that continuous deployment, really highly automated, fastest possible application delivery. So these two solutions together, the idea of CaaS platform and a PaaS on top of it, are the tools that you need to really realize the cloud native vision. And whether you start piecemeal and move over time, we can help you along that journey with these products and with our services and support and our consulting. For more information, definitely go check out our website. You can see information pages for both products. We also have just launched the SUSE developer community. Check that out, because at the SUSE developer community, especially if you're a developer, you will find that you can access a free developer sandbox where you can go in and you can use SUSE Cloud Application Platform and get a sense for that advanced developer experience. And finally, here we are at SUSECON Digital. Do not miss the opportunity to take advantage of all the resources that are here. Go to the session site, sort for container and application platforms. You'll see dozens of sessions here at SUSECON that you can avail yourself of to learn about how to install and manage and build cloud native and all kinds of great stuff that you can do, integrate with your CI/CD, all kinds of stuff here at SUSECON. Don't miss the opportunity to take advantage of that to learn more. And now I'm also available if you have questions. Please submit your comments here. You can send me email. My email address is on the first slide. If you have any questions, you can also visit me at office hours. They are posted in the session summary if you go back and look at that. And I look forward to hearing from you and hope that you found this an enjoyable and useful session. Thanks for joining. Enjoy the rest of SUSECON, and I hope we talk to you soon. Thank you.